Hi! First of all, I want to thank Imarest and Nickel for this opportunity to hold this webinar for all of you. My name is Kjetil Olsen. I'm the Business Director of Safe Almat. I have been working with surface protection for more than 30 years, and with Core Solutions since we started up Safety Tools for more than 22 years ago. We also have with me Tony Berge, who is the Technical Manager in Safety Tools Almat for the last 18 years. He has his background for mechanical and welding operation. He's responsible for the ATEX Certificate and the testing we do to achieve tools operating as cold work. I will also say welcome to Steel Core with Leo Diaz, who has worked with the paint industry for more than 20 years. He holds NAILS and FUSU Paint Inspector certifications. Leroy will give us an explanation about surface preparation and the importance of the right surface profile during onboard surface maintenance. Leroy will also talk about how the heat from standard hot work grinding tools will affect a paint surface.
Thank you, Kjetil. I'm Tony, the Technical Sales Manager at Safety Tools Almat. First, we will present relevance of ATEX zones. In ATEX regulations, hazardous areas are classified into 3 zones for both gas and dust environments. In gas zone 0 or dust zone 20, an explosive atmosphere is continuously present or present for a long period. For example, inside gas, storage tanks or pipe containing gas. Gas zone 1 or dust zone 21, an explosive atmosphere is likely to occur under normal operation. For gas zone 2 or dust zone 22, an explosive atmosphere is not likely to occur under regular operation, and if it does happen, it will only exist for a short time. That is ATEX zones. Next I will talk about ATEX certificates. ATEX certification has changed a lot since the start in 2005. The current ATEX certificate we use are from the first introduction of ATEX certification. And the markings are also from the same first introduction of ATEX. The real meaning for the numbers and annotations on the certificate we have at the moment follows. The marking starts with the explosion hazard environment logo, the ATEX logo. And then we have the Roman numerical 2. This tells us the equipment group. Equipment group are 1 and 2, presented in Romanian numbers. In our case, will our tools be marked with Roman numerical 2, which is for the apparatus to be used on Earth's surface, where the danger is represented by gas and dust. For group 1 is apparatus to be used underground in mines, where the danger can be methane gas and coal dust. The A, B and C in the certificate. For a gas certificate marking, the equipment group is subdivided into 3 gas groups. Group 2A, meaning surface tools. Gas group A is for propane. And the same for group 2B, but that is for ethylene gases. For group 2C, it's the hydrogen or acetylene. And group C covers both group B and A. If the ATEX marking show only the Romanian number 2 without A, B or C, as in this example taken from our certificate, is the A that is applicable. The number 2 in the ATEX marking, equipment category 2. Equipment that are marked with 2 in the ATEX certificate allows us to use the tools marked with the number 2 for both gas zone 1 and 2. Equipment category 2 also covers equipment category 3, which is gas zone 2 and dust zone 22. The capital G. G stands for gas environment, which typically are on board an oil tanker or on a platform or on a petrochemical plant. And more, of course. If you change the capital G with a capital D, the certificate is for dust environments. And it's typically for food industry like a flour mill or around grain storage tanks, and more of course. The small letter C in the ATEX marking is for construction safety. The equipment marked with C tells us that these tools are made with construction safety and with materials that are safe to use in an explosion hazardous area. And then the T3, that is the temperature class. For gas is temperature class T3 equivalent with maximum temperature of 200 degrees Celsius. For dust certificate marking, the maximum temperature is marked with the actual number achieved during testing. For example, is a tool marked with T4. It is a dust certificate telling us that the tool will have a maximum temperature of 135 degrees Celsius. Thank you, and now over to Leroy.
Thank you, Tony. Good morning, good afternoon, or good evening to you, depending on where you are at the moment. Thank you once again for tuning in today. We wanted to dwell a little bit on the important elements of a good surface preparation. As we all know, when it comes to paint application, the critical success factor is the surface preparation. In fact, a moderate paint system that has been applied to a well-prepared substrate will perform much better than a highly sophisticated and often expensive paint system that has been applied to a poorly prepared substrate. There are two elements of surface preparation and both are equally important: surface cleanliness and surface profile. Surface cleanliness ensures that there is no contamination present on the substrate that could interfere with the adhesion of the paint. Surface cleanliness is denoted by standards such as SA2 and SA2.5 for abrasive blasting, and standards such as ST2, ST3, and SSPC, SP11 for power tool clean surfaces. Surface profile, on the other hand, ensures that the paint has sufficient anchor or grip to hold on to the surface, and that is defined in terms of microns, which 1 micron being 0.001 millimeter. You may have heard terms such as 40 or 50 micron profiles, which basically mean that the surface roughness is 0.04 or 0.05 millimeters. One of the best ways to understand the relevance of surface profile is to imagine you trying to apply paint to a smooth glass surface. It would be relatively easy to remove the paint from that smooth glass surface as opposed to if the same paint was applied on a very rough surface. So, surface cleaning and surface profile both are equally important, and it is therefore important to verify that the method of surface preparation used by the teams not only generates a clean surface, but also that it does not create a polished surface as generally happens with most power tools being used currently. So now we talk a little bit on the conventional tools used during maintenance. It is a proven fact that when most of the current conventional grinding and surface preparation tools are used on a steel surface, even for a few seconds, it raises the temperature of the steel surface to over 250 degrees centigrade. So we have to ponder, is the paint system in the immediate vicinity of the area being treated or at the back of that steel plate being treated capable of withstanding such high temperatures? Or are we literally frying that paint? Most paints can tolerate 120 degrees centigrade, some maybe to 150 degrees centigrade, which means when we expose it to temperatures of 250 degrees centigrade plus, we are damaging that paint and it will need repair within the next couple of months. So effectively, while we are repairing the paint in one area, we are potentially damaging the paint in the vicinity and the surrounding areas, and it will need to be fixed in the very near future. That is a vicious cycle. So, what are the alternatives to hot work? When it comes to surface preparation, you have the options of hydrojetting and vapor abrasive blasting, which cover large surface areas. Hydrojetting is also used for cold cutting operations with pressures up to 30,000 psi. However, it needs skilled operators since you are dealing with very high pressures and can pose a safety risk if not used correctly. Apart from the huge costs, the hydrojetting machine itself weighs about 6 tons, thus becoming a logistical challenge to mobilize. The other challenge, of course, is that the water, along with the contamination, flows overboard, and this could pose a problem depending on your vessel's location. Hence, please be very careful when making a choice. That's it from me. I now hand you back into the very capable hands of Tony.
There are huge benefits when comparing cold work abrasive tools to hot work abrasive tools. For example, vibration is a factor with huge differences. Hot working power tools and traditional needle guns are typically tools that expose ill effects and cause white finger diseases. What is hand-arm vibration? Hand-arm vibration is vibration transmitted from work process into workers' hands and arms. It can be caused by operating handheld power tools such as grinders and sanders, and all other hand-operated power equipment. Some tools expose more vibration than others. Needle gun is one of the worst. When is it hazardous? Regular and frequent exposure to hand-arm vibration can lead to permanent health effects. Occasionally, exposure is unlikely to cause any ill health. What health effect can it cause? Hand-arm vibration syndrome is known as white fingers or HAVS, as well as specific such as carpal tunnel syndrome. The effect on people include pain disease and sleep disturbance, inability to work fine, for example assembling small components, which will trigger painful fingers and blanching attacks, reduced grip strength, which might affect the ability to work safely, the exposure limit, the maximum amount of vibration an employee can be exposed to on a single day. The maximum ELV is 5 meters per square second. However, the lower the number the tool is tested to give, the longer you can use a tool each day. Next out is Kjetil, who will take you through isocyanates. Thank you.
All paint, for example polyton coating, can contain isocyanates. With use of tools that make a hot surface moving paint, will the isocyanate and the danger fumes release. And this is a danger for the operator. When using tools that cold work and spark free, you lower the release of the isocyanate. Using low RPM tools and special rotating files and discs makes fragments from the paint or the rust you remove not to get airborne. The fragments will lay down beside you and you can easily be removed after the job is done. At the Institute of Chemical Analysis Norden AB in Sweden, they tested special low RPM grinding tools and normal high-speed grinders. The test result was extreme. High-speed tools produce more than 500,000 airborne particles per cubic centimeters. Low RPM cold working tools produce maximum 10,000 airborne particles per cubic centimeters. So now, are you ready for a demonstration? This is a typical ATEX solution suitcase, ready for
Grinding and cutting.
grinding and cutting. So now I think it's important that we show the big difference between hot work and cold work. So I think we're going to do a demonstration where we are showing both sides, cold grinding, hot grinding. So Tony, about the EX and ATEX certificate for all the tools that has ATEX directive, is that something that the customer can easily see they have a cold solution instead of hot solutions?
Of course. For cold solutions, all tools are marked with an EX certificate number. This number can you also find in the EX certificate, like this one from DNV.
So that means that every tool that has a cold solution that is certified will have a special ATEX number that you will find on all kind of equipment that has these numbers on it.
All the rotating parts on the equipment will be marked with this specific number.
Yeah. So that's the biggest difference between hot work and cold work. That means the cold work who has this
Doesn't have the certificate.
Yes.
Easily is that.
So that means it's easy for the customer to understand what is cold work and what is hot work.
Absolutely.
Experience grinding and cutting without heat and sparks. The Norwegian company, Safety Tools Almet, supply cost-efficient EX certified equipment for cutting and grinding. You can cut steel or any other material without making a hot surface or any hot sparks that can ignite natural gas. There is no airborne dust, low noise level, and no sharp fragments. It's incredibly safe to use. Our spark-free grinding and cutting tools are certified by DNV, the Norwegian Veritas, as cold work. Safety Tools Almet grinding and cutting tools are also super efficient outside your EX areas. Our tools are designed for steel grinding and paint removal, and to make any surface ready for new coating within the SSPC SP11 standard. We offer the most efficient tools in its class with significant HSE benefits. Safety Tools Almet, cut the heat, cut the risk.